All right. We're a little bit early, but we can go ahead and get started, huh? Sure. All right. All right. So we can start off with some introductions. So my name is Steve Mills. I am a mechanical engineer at Meta and a member of the incubation committee for OCP, representing Cooling Environments Track. And Loren?
I am Loren Vorreiter at Google. I'm a mechanical engineer and mechanical lead for the racks at ORV.
So we're going to go through the OpenRack V3 base specification. So the base specification supports both the OpenRack, the 21-inch form factor chassis, and it also has native support for the EIA 19-inch specification. So this is a kind of an addition that we've made to the new V3 specification. OpenRack V3 is really about flexibility, and so this is just kind of one example of that. Oh, not that way. There we go. So we've increased the gather on the interconnects that go between the IT gear and the bus bar, so to kind of give us a little more flexibility and I guess improved quality when we make those blind interconnects. And then the power shelf for V3 is now movable within inside the rack because it plugs in directly into the bus bar. On V2, we had very defined positions, which made it a little bit more difficult to have a lot of flexibility for the IT gear designed for the rack level. So this makes things much easier to build upon. And then finally, the fact that we can plug multiple power shelves into the same bus bar gives us the ability to incorporate multiple power shelves or BBUs or any other type of bus power system on the same bus bar, which makes it much more extensible, right? So you can plug in one or two power shelves to increase the amount of power that's capable. So things that you'll notice in the new specification is that we've got two options, which have different bus bar location options. There's also support for different IT gear widths. And then we also have different voltage ranges depending upon whether you're picking option 1 or option 2. So this is somewhat similar to what we had in V2, where we had different options in depth that were allowed within the specification. So this is a base specification. So in OCP parlance, that means it's supposed to be the very bare minimum requirements that are needed to maintain interoperability between the IT gear and the rack itself. In the details, you'll see that we've really kind of focused just on the minimum needs to kind of define those interactions between the two and left as much flexibility to build different types of products or meet different kind of customer needs outside of that. And then finally, we have additional requirements over what we had in the V2 specification related to the casters, environmental, and overall testing of the rack. So we've got a little bit more consistency on the capabilities of the systems. So I know this is kind of hard to read, but this is the kind of the cross-section for the option 1 rack. So the point of this is that you can see that the specifications that are in there are really defining the internals of the rack that impact the IT gear. So how it latches into the rack and then how it plugs into the bus bar. That's really all that's controlled in this, right? The outside of the rack isn't controlled. The depth of the frame isn't controlled. None of the heights are controlled. So that gives us a lot of flexibility to users to vary their solutions around what they want. You also see there in red at the top and the bottom. So we've got some optional keep-out zones. That's primarily around the liquid cooling manifold, right? If you have a blind mate manifold for the IT gear, that's the locations of where that will be. So if you can avoid those, then you'll have a little bit more flexibility in your solutions. Details around exactly How to interface with that manifold will be coming a little bit later on. They're still working out those details right now on the manifolds as we showed yesterday in the cooling environments project. So those are coming. They're just not part of this particular layout just yet. So as I said before, we support both the vertical heights of the chassis in both OU, which is 48 millimeters, and we also support the EIA natively for the 19-inch EIA type racks. So the point of this is just to show that both of those are natively integrated into the solution, so you can take advantage of that as you need. And then it's up to you, Loren.
Yeah. So Steve mentioned this, but I want to reiterate this. All of the spec is written as outline spec, right? We're not defining external dimensions of the rack, height, width, or depth, right? It's all about defining what the interface spots for payloads that go into the rack. And so it's inner dimensions of the shelf, bus bar location relative to whatever critical dimension we have for latching either shelf, rails, or packing. So you won't see any in here anywhere mentions of overall width. Right, but so this is, and we tried to do multiple options because we know that different deployments will have different needs. Center bus bar in option 1 is great for power routing, right? And power guys love the fact that it's symmetric. You're bringing power into your BBU and dividing it symmetrically. This is a different option where you have a bus bar located biased on one side. And it gives you a couple different advantages. Giving a talk in a couple hours, a little bit more detail on how that benefits you from a rear serviceability of equipment for being able to move equipment away from the bus bar. But option 2, so a couple things of note. Inner shelf dimension is 610 millimeters, and so that's your rail-to-rail dimension where you can fit your equipment into. And then we have, within option 2, we have two depths of the rack. As everyone's cramming more stuff into equipment, we're running out of height, everyone's going deeper. And so we have a version of the rack which is a deeper rack. Again, this goes to deeper equipment, centered, we're doing mid-plane designs on some things, and being able to go deeper with the rack deeper with equipment inside the rack is really beneficial. So I'll show it a little bit in the next slide, but we have a datum, our datum A, which is a screw hole in the side of the rack, which locks in your payload to bus bar, leading edge of the bus bar. So that's our critical to function dimension that we hold within the rack. We do have in here clearance in the front for handles, cable management stuff. Any beyond that, where are we? Okay. Just as option 2 versus option 1 has different payload widths, it also has a different mounting scheme. This is just an alternate, right? So we have, for each of the half OU increments within the rack, we have 3 features that you can use to lock in a shelf or a payload. We're using a two-threaded threads in the rack, an M4, which is our datum for locking equipment to the bus bar, and an M6 if you want to use that. We've decided to go with screw versus a toolless design, just because as we're getting heavier with equipment, we want to be a little bit more secure in mounting equipment into the rack. Toolless designs have great advantages. Sometimes they're not quite as robust, but this is an option if you want to hard mount things into the rack. And then we have a third feature, again, on every half OU, which is a cutout for a spring latch if you wanted a toolless shelf in there as well. Bus bar, do you want to go through this?
Yep, I'll take that. Oop. Thank you, Loren. All right, so we've modified the bus bar for OpenRack V3, again, as I mentioned earlier, to improve the gatherability. We've also added some additional features associated with it. So to begin with, you'll notice that the kind of leading edges of the bus bar are different than what we had in V2. That's specifically for gather, so as that connector from the IT gear comes in, right, it'll be able to find that spot on the bus bar blind. So you'll see the additional features also related to the connectors as well a little bit later on today. So something else to note is that we define the geometry as it enters the bus bar, but we have not really defined much of the geometry behind the interconnect on the bus bar, and that's very similar to what we did on V2. And the reason for that is you'll notice that the width is set at 35. That's mainly so it'll not hit the IT gear, but the depth at the bottom there, the 61 dimension, is a reference dimension. So you can make that bus bar depth as deep as you would like. And then there's that crosshatched area there that's in orange. That is reserved for mounting the bus bar inside of that volume, but it doesn't tell you how to do it or how big the bus bar is in that space. And the reason for that is it gives you the ability to add as much copper as you need to in that volume, so you can kind of optimize the power carrying capability of the rack. So you could, if you've got a 10 or 12 kilowatt rack, right, you can have a very small bus bar in that space and save the copper. But if you need to use 40 or 50 kilowatt rack, then you can fill that space with whatever current carrying capability you need. So this gives the customer's ability to optimize the cost of their rack around their particular power levels. So that's an area where we can kind of make the rack much more extensible across a wide range of customer use cases. We have also added in this green area where we have the ability for the connector to ground directly into the bus bar. So you'll see later on today on the connectors that we've added some contacts on the outside to provide a chassis ground. And these planes that are inside the bus bar, once they make that connection, are also grounded directly to the rack frame. So now you've got a much more controlled and reliable, repeatable ground between the IT gear and the rack frame than we had on V2. So this is optional, it's not required, but some users find this very, very helpful. Others don't necessarily see as much value in that. So it's available if somebody wants to use it. And finally, we've got two different voltage ranges on the bus bar. So there's one that's for option 1, and then we've got another optional voltage range. Optional range, it's a pretty much required range, but for option 2. So those kind of updates we've got on the bus bar. So
actually, one more on
sure.
the bus. One more on the bus bar. Hard to see in here, but the return bus bar and the 48-volt bus bar are staggered, so that the return is proud. So that is a first mate, last break on the bus bar.
Yes, yep, that's very true, and that's also similar to what we had on V2, right, where you could you'd have that the ground hitting before power hits. Yep, that's a good point.
Where are we?
That one right there.
Another one.
There you go.
Okay, casters, right? So casters are always an interesting topic that we get in with racks. We don't in the spec call out a specific vendor, even specific geometry of the casters. We do put some critical dimensions in here. Actually, we don't specify how many or even physically where the casters need to be. We do require, we add in here, wherever they are, that you have an entry and exit angle of 10 and 15 degrees, so that you're not hitting a threshold as you roll the rack across the floor. Again, height, you can vary that if you want, but you have to meet the entry and exit dimensions. And of course that they're full 360 swivel and stay within the outline of the rack. We don't want feet rolling out of there. We've added a significant number of tests to the casters. I think some of these were already there, but we've added and expanded on impact compression, creep and acceleration, just to know that when you get an ORV3 compliant rack, that you have a robust caster design. Similar to casters, even the other stepchild is the leveling feet. Important. We don't specify diameter or specify exact location or even number, but the fact that they have to be able to protrude 15 millimeters off the floor and have a pad diameter that comes down onto the concrete or surface of 30 millimeters in diameter.
There you
go. Okay, so beyond dimensions and the overall spec of it, we've added testing specs and grounding for here. So the normal safety, the UL, all of that's kind of table stakes for any rack design. And we have in here any plastic material that you have either in the bus bar or if you're putting anything in there has to be 94V0 rated material, right? We don't. Color and marking, we don't define whether or not it's painted, what color it is or anything, but we do define that you have to have marking at least every OU throughout the rack. If you want to put it every half U, fine, but at least every OU is marked on the front for location. And then grounding locations, right? Again, we're not specifying whether it's painted or not, but we do need to ensure that you have ground locations for ground straps. And so those are locations defined on the top and in the rear of the rack. Additional specs, this is not the right forum to go deep into, a roll-off test or whatever, but we've added and expanded from V2 for additional testings that needs to be done on the rack. I talked about the casters and the leveling feet. Another obvious one is the tilt over test, the 10 degree, it's got to right size itself. And then some ramp and threshold tests within the rack. Is that it? Oh, call to action.
Yeah, all right. So from a process standpoint, last week the team sent 10 different specifications, including this one, to the incubation committee for final ratification. So it should be hopefully ratified and out on the OCP website here in the next couple of weeks. So once that's officially published, then we'll definitely include the links for that out on the mailing list and send it out to everybody so you can go and take a look at the rest of the details. The preliminary specifications that we sent to the IC are already out on the Rack and Power Wiki if you want to go and check that out now. I don't think we made any changes between what we submitted, so unless there's something the incubation committee asks for, that's pretty much the final version of it. And then if you would like to get more involved in the Rack and Power project, there's some links there where you can either join the mailing list and keep track of what all is going on, or actually see what's going on if you hit those QR codes. We are definitely looking for what new kind of features or needs the community has to go work on kind of the next revision of the V3 specification, right? So what is missing now that the community needs to go incorporate in as we go forward? So we'd definitely like to hear feedback from anybody on that particular topic. So I think that's all we've got for today. If you've got any questions or anything, we've got some mics up here. You can ask us questions while we still have a little bit of time.
Yeah, and even in addition to questions, we'll take them now. But
should be an easy one.
On the ones on the side, if you want to come ask us questions too, afterwards.
Yeah,
welcome
absolutely.
But yeah.
At the beginning, you said that the rack has provisions for EIA 19-inch width. There's no Retma rails on the rack, so I just wanted to ask, what do you mean by that statement?
So we have a series of holes on the side, right, that appear every, what is it, 44.45 millimeters. Yep. So it's at the EIA spacing. So if you want to make some sort of adapter or something to put the holes into the rack, or you have a facility in order to do that.
So it's really EIA height.
Yeah.
That you're supporting.
It's really EIA, what was it?
It's really the chassis height is what you're supporting.
Yeah. Yes.
There's no specific support for EIA width.
Not in the base specification, right? So, but you can easily, and that's again something maybe we could contribute or something like that, but it'd be very easy to add additional bolt-on adapters to add those, the more traditional rails so that you can pop in your EIA gear. But yeah, it is an additional component you would need to add in order to incorporate that.
Suren Babu from Pandavit. I see one bus bar per cabinet, right? Like, how do you support redundancy? Like feed A, feed B, how is that supported?
So there is no, I guess, multiple like DC inputs into a particular component of IT gear. So if you want redundancy, right, you can do that at the power shelf level, right, where you can have an A and B feed that go into either one or two different power shelves. Since you can support more than one power shelf per rack, right? So one way to do it is to have two power shelves, one that's going to your A feed, another one that's going to your B feed, and then those would have multiple power supplies inside of each one, feeding into the DC bus bar. So at that point, you could have multiple AC feeds into the same rack if you want. You could also do it with a power shelf that has both one, say, power shelf that has both an A and a B feed into it. And do the switching inside of the that rectifier shelf if you want that in a single chassis. That's really up to the community to decide how you want to implement that. Later today we will have a presentation on the meta version of the power shelf, and it's capable of supporting more than one power shelf per rack or per bus bar. You can also break it up where you can have a bus bar at the top half the rack, another bus bar at the bottom half of the rack. So if you want to reduce the blast radius of losing a particular feed, right, you could also do it that way. You might lose half your equipment, and that might be perfectly fine. Just kind of depends on the scale of your deployment and what your risk versus blast radius requirements are. Is that kind of what you're looking for? Okay, sure. Go ahead.
Hi, I'm Rajiv, and I'm from Enersys company. My question is, actually, I'm coming from telecom-based power system designs. Mm-hmm. The systems we ship, manufactured, like 99.9 systems are like 23-inch rack space width. So now we are talking about changing the telecom-based central offices into data centers in the future. It's called, there's a concept going on, it's called CODE, Central Office Restructured Data Centers. So my question is why you picked 21-inch racks instead of 23-inch rack? Because in the future we can use same rack in the telecom market and the data center market.
Yeah, so 21 inch has been around for 10 years now. And so the reason we picked that wider width, so the rack itself, like the outside of the rack, at least for the meta version, is 600 millimeters, which is the same nominal width that you would get on a 19-inch EIA rack, right? So the actual rack frame itself on the floor is the same width. It's just we use the volume that's normally reserved for the frame for IT gear. So we can actually fit more stuff into the 21-inch rack when compared to a 19-inch EIA rack, because by kind of removing the width for the structure that normally goes into the rack frame. So the reason we picked that width originally was because it allowed us to get 3 half-width motherboards into the rack. As opposed to 2, because they were originally, you get 2, they're about 8 inches wide at the time. You get 2 of those into a 19-inch, and you get 3 of those into a 21-inch, because a 19-inch rack is really only like, 17 and a half or something like that. So that's how we ended up with the original 21, is we wanted to get 3 motherboards and X number of hard drives in those original systems from 10 years ago. And that extra width, people that develop hardware really like that extra width when they're trying to build out IT systems. It's just very convenient to have that extra space. So that's where we ended up with 21 as opposed to 19 or the 23 EIA.
Yeah, with like 5G networks, most of the telecom space will be edge data centers in the future. So I see a conflict between telecom and data center racks. Yeah, that's fine.
Sure, sure. So there's definitely a lot of work that's going on in the open compute telco area, where they've got a lot of chassis work that's going on. Some of them are 19-inch, some of them are 21-inch. So it just depends on what you're trying to optimize around. But yeah, right now a lot of it is that 19-inch EIA-based stuff. But it is that's what it is right now. The 19-inch stuff all fits inside the 21-inch, right? Because the width is for the 19-inch is smaller than 21, and the height is 44, and we have 48. So it all fits inside that same volume. So if you want to incorporate it, it's just a matter of adding some adapters in to fill the space up that you're not using for your that 19-inch gear isn't using. So it's just kind of some wasted volume that you could have taken advantage of, but at least you can use more standardized stuff. So again, it's kind of a trade-off.
Yeah.
Okay. Oh, okay. All right.
Question?
Yeah.
Hi, this is Lam from eBay. I just wonder if the spec define any height limitation or weight limitation of this.
Loren, you want to take that one?
So we're not taking overall height in there. We wanted to leave that flexible for different deployments. I mean, different, colo site for, custom design data center could have a different height for overall rack. So we didn't want to put that in the spec. And well, the weight is kind of tied to that, right? I mean, if you want to have a, half, 42 versus a 21, OU rack, I mean, you're going to have a different weight. So we did contemplate doing a, weight per OU type of a spec. We ended up not putting that in there. So we do have just kind of a overall capacity, max weight of the empty rack, but not as far as a loaded. So,
Thanks.
yeah.
Hey, on the list of test specs, I didn't notice anything with seismic. Is there a seismic requirement test spec?
Sorry, can you say that again?
Seismic.
He's asking about seismic. So no, there's no seismic requirements in the rack right now. I don't believe, right? We didn't put that in. Yeah, we talked about it. We didn't put that in. And the reason for that is because this is a base specification, we want to make sure that it's as broadly applicable as possible. So we put that seismic requirement in there. We don't want everybody to have to comply with that if for some reason they don't need that. That's definitely an area where there might be some value going forward, right? Where we may want to develop another specification of how to convert the base specification into a seismic capable solution. So that'd be good feedback from the community, right? Is that something that we should be working on? Is that something that adds value? If so, then that's great to hear. And we can put that potentially on our roadmap for things to go look at.
One possibility, if we go into that, where this is all internal dimensions, interface specs, we could define a external dimension for different seismic rating, seismic sites.
Yep, absolutely.
That's great.
Absolutely, yep.
The option 2 rack doesn't show any keepouts for manifolds.
Sorry, what was that?
The option 2 rack doesn't show any keepouts for liquid cooling manifolds.
No, we did not put those in there as far as in rack. We're leaving that for an external rear mounted to the outside of the rack.
Like a rear door.
A rear extension. So we do define in the spec mounting points on the rear of the rack for putting a manifold. We didn't put it inside that geometry, partly because we think that would be right around where that rear left bias bus bar would be, and so you go beyond that and go deeper in the rack.
Yeah, we can.
All right, thank you.
But
Yeah, so if you had the manifold over on that side, it's kind of right where the bus bar is. So. Any other questions? Okay.
Right.
In that case, thank you very much.
Thank you.